In the previous section, we defined the definite integral, and as you see in that records, definite integral of a function f on an interval ab is a number. The area, this number is the area between the graph of f and the x-axis from x equals b a to x equals b. The indefinite integral of a function is a family of antiderivatives. In this section, we explain the connection between these two integrals, a connection made precise by fundamental theorem of the calculus. This link can be given in the following theorem. If f is a continuous function on the closed interval ab and capital F is any antiderivative, one of them is enough, it has to be a family. Antiderivative of small f, then the definite integral from a to b f of x dx equals capital F of b minus f of a. So this put the relation between the antiderivative and the or indefinite integral and definite integral. Actually, you can recall the integral of the f of x equals capital F of x plus c. Okay, so there is a direct relation between the antiderivative and the derivative, as you see. Okay, now let's make an observation about this theorem on the simple example. Suppose that the daily cost function for a small manufacturing firms is given in dollars by this function. Okay, this is the total cost function. Exchange between 0 to 20. Then the marginal cost function is given in the dollars per unit by this formula C bar of x. This is 118. Okay, this is total daily cost, total cost. This is marginal cost. What is the change in cost as production is increased from 5 units to 10 units? Okay, easily you can calculate the change in cost from 5 to 10 units, okay, which is C of 10. This is total cost. This is C of when the production level is 10 minus C of 5. This is the total cost when the production level is 5. So this difference gives us the change in the cost. Directly you can calculate by using this function times 10 plus 200 minus 180 times 5 plus 200 cancel, so 118 times 5, so this is $900. So actually when calculating this one, I said that this is 118 times 5, so notice that from here this constant term cancelled, so this is 118 times 10 minus 5, so this is 118 times 5. Okay, this is 900. So this is equals to area between the graph of the C bar and the x-axis from 5 to 10, okay? So you can sketch these two graphs. The total cost graph. When x equals 0, this is 200. When x equals 20, it is 200, 3,800, etc. Okay, so this is 200. You can check. This is C of 20. If I'm correct, this is 3,800. Okay. This is the graph of the y equals C of x. Let's sketch the graph of the marginal function. This is constant. So this is the graph of the y equals C prime of x, which is 118. Okay, this is 118. So from 5 to 10, this is 5, this is 10. The area of this region exactly equals 118 times 10 minus 5, because this distance is 5, this distance is 118, so this is 900. Okay, as you see, these are the same. What does it mean? This area is the integral of this function. So this area equals integral from 5 to 10 the function c bar x dx. C of x is the antiderivative. So this is c of 10 minus c of 5. It is as it is indicated here, okay? So as you see, we can conclude integral from a to b c bar x dx equals c of b minus c of a in general, and here this c is antiderivative of c bar x. So as a result, we obtained this theorem, which is known as a fundamental theorem of the calculus. Another important topics of this section is the average value. So recall that the derivative of a function f was defined in the first term by using limit. Derivative of the f of x equals limit h goes 0, f of x plus h minus f of x over h. This form is generally not easy to compute directly, but is easy to recognize in certain practical problems: slope, instantaneous velocity, rate of the change, and etc. All of them were discussed in the first term. Once we know that we are dealing with a derivative, we proceed to try to compute the derivative with the use of derivative formula and rules. Similarly, evaluating a definite integral with the use of the definition, we gave the Riemann sum. This integral equals limit n goes infinity f of c1 delta x1 plus f of c2 delta x2 plus blah 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 f of cn delta xn. Here n was the number of the partition of our interval AB, and c1, c2, blah blah blah, cn are the sample point on the each subinterval. Delta x1, delta x2, delta xn are the distance of the or length of the each subinterval. In general, it is not easy to calculate this integral by using this limit. Okay, we can use the fundamental theorem of the calculus to evaluate this definite integral. In this section we learn. Okay, if you can calculate the antiderivative easily. Otherwise, we will approximate it with a rectangular sum by using this sum. We will now illustrate these points by finding the average value of a continuous function. Okay, the area A of a rectangle with width W and height H is given by the W times X. W times H, sorry. So, okay, let's show that the graph. For any rectangle, this is W, this is H. So the area is W times H. The height of a rectangle is then given by the, from here, H equals A over W. For this side area under a continuous curve f of x on an interval AB, the width of the region is B minus A, and the area of the region is given by the integral f of x from A to B. Okay, let's show that this situation on the graph. This is our graph, for example, from A to B. The rectangle is this rectangle. This is the rectangle. Okay, so actually our area under the graph of the f of x and the between the A to B is this area. So this is the extra here, and actually this part is missing. Okay, so the height of the rectangle with the same width and the area is then 1 over B minus A times integral from A to B f of x dx. Okay. Why? Actually, please look to this formula. W is B minus A. Area is this integral. Okay, so from this formula we write area from A to B f of x dx. The weight is the B minus A for the rectangle. This is the W, which is B minus A. So H is the average value. So this is the average value of the function. So this is the average value. So what does it mean? There is a such H value. This is the H value. Maybe this is not good H value. Yes, actually the H value is the some value. So this area or this product give us the integral, or for the average value, this is H. Okay, let's show that. For example, this is the H value. Okay, so this area exactly equals to yellow sheeted region area. Okay, this length is H.